My dear friends, today we'll discuss about segmented paging. We are going to use the two concepts. One is segmentation. In the last video we have seen. Previously we have discussed about paging. And this two concepts, segmentation and paging, together we are going to apply in some architectures like Pentium architecture. Right now we are using this technique, using this segmented paging. See this paging, first we learned about paging. In paging, what we have done is logical address space and physical address space are divided into an equal parts. That means page size is equals to frame size. Okay. In segmented, segment size is varies. Programmer writes a program into different segments. Program is one segment, data part is one segment, stack is one segment, symbol table is one segment. Suppose any function a programmer is using like square root, it will be one more segment. So segment size here varies. It is not fixed like frame size or page size. Understood? Segment size may varies. It may be one segment may be 10 MB, the another segment may be 1 MB, and so on. Now how this works, let us discuss now. Any given program is divided into segments. So into different segments, it is like main program, or subroutine, stack, table, symbol table. The program is written into a different segments. There one more segment you can add a data segment. Okay. Now using the segmented paging, we are going to have a segment table. Segment table, outline I am telling, the segment table. The job of the segment table is to store all these segments base address and limit address, where this segment is stored in main memory. In main memory, it is going to be stored. In the previous video I have seen, this is main memory. So segment 0, segment 1, segment 2, segment 3, segment 4. Each segment is stored. This is base, this is limit. In which location, suppose this is segment 0 is stored for a base at this is here 1000, it is stored at the 1000 location. If its size is suppose 50, up to 50, this is 1050. This is the segment. Like these segments are stored in different sizes and stored in the memory. The segment table gives the address where it is, the segment is stored in the main memory. That is the concept. Now my dear friends, each segment has a memory. Each segment has its own size. Then each segment, suppose this is a segment 0. Segment 0, for example, 8 KB size. Okay, my dear friends. And segment 1 is 10 kb. Okay. Now in this segmented PG, this 8 kb segment is divided into number of pages. This segment 0 has a unique page table. This page table is only for this segment 0. And segment 1 has page table. Again a page table. This page table has the number of pages this segment is divided. For example, this is page size is 1 KB, for example, then 8 pages are stored. This segment is divided as 8 pages, whereas segment 1 is divided as 10 pages. Now these two tables, these two page table, each segment has its own page table, and segment 0 and its page table both are stored in main memory. Segment 1 and its page table both are stored in main memory. Understood? Now let us see the architecture of the segmented paging. Now the entire program is divided into segments, and each segment has its own size. Sizes varies, 8 KB or 10 KB like that. And each segment is divided into number of pages, and page table will store here divided into entries of number of pages, and page table will be having frame number. Frame number represents main memory. Okay, main memory frame. Now let us see the architecture or hardware diagram of segmented paging. Please remember the following important points. Each segment, the program is divided into different segments, and each segment has its own page table. Understood? That page table is stored in main memory. That is the most important part. CPU, here CPU generates all segment number, page number, offset. This is logical address. We have seen that entire program is divided into segments. Which segment? There are suppose 4 segments, means we need 2 bits here. Again, in a particular segment, number of pages. How many number of pages? Suppose segment size is 8 KB. Then page size is 1 KB. Then we need 8 pages, means 3 bits we need. Okay. And this is an offset. Now let us see the hardware diagram. This represents to segment table. Segment table. What is the segment table will have? Segment table always have base register and limit register. A particular segment where in the memory, main memory, it is located, and its range we are going to get in the segment table. From this, page number, and this gives to page table. This is page table, and from here this is frame number and offset. This offset will be as same as logical offset. This is physical address, PA, physical address from this main memory. This is main memory. My dear friends, let us see this architecture. This architecture, we have CPU generates a logical address, that is here segment number, page number and offset, and this segment table gives which segment is stored in which location in the main memory, and page table, then the particular segment is divided into number of pages. This is page table entry. In number of pages, the segment is divided, and in each entry will store frame number of the main memory. A particular segment is divided into number of pages. In that particular entry in the page table, we are going to store frame number of the main memory. This is the segmented paging hardware architecture. Understood? Now, based on this, let us do one problem. Then you will understand exactly what this diagram means. Please kindly note down the problem. The problem statement, kindly note down the problem statement. The problem statement is like this. Virtual address and physical address are 2 power 16 bytes. Which virtual address space, physical address space are given as 2 power 16 bytes. Okay. Next, virtual address is divided into 8 segments. How many segments is divided? Total 8 segments it is divided. Now, memory unit has a hardware segment table. Hardware segment table. Segment table. What is the segment table contains? There are 8 segments. All these 8 segments should be stored in main memory. In which location? 0 to 7 is 0 to from segment 0 to segment 7. Which location it is stored in the main memory will be maintained by hardware segment table. Okay, follow the question. Each entry of which contains the physical address of the page table for the segment. Okay, what does that mean? Each entry, I'll repeat once again. The problem statement, which has this problem has come in GATE examination, please note down. Each entry of which contains the physical address of the page table for the segment. Suppose this is 1000. In the main memory, at 1000 location, what is stored? It seems this is segment 0. Segment 0 page table is stored in 1000 location. Understood? Each segment, this is segment 1. Suppose it is started with 2000. Here 2000 onwards PT. This is PT. PT of segment 0. This is PT of segment 1. Each segment is divided into number of pages. So each segment should maintain its own page table. That page table address it's giving, that is a problem. In the problem it's given like that. Each entry of which contains the physical address of the page table for the segment. Next, page tables are stored in the main memory and consists of 2-byte page table entries. See, here page table stored. Where it is stored? For segment 0 page table. This is stored in address 1000. Here each entry, how many bytes? 2 bytes. Means 16 bits. Understood? Page segment 0 is divided into number of pages. So it should maintain a page table. That page table stored in main memory in the location 10,000. That is it. And each entry in the page table is 2 bytes. Okay. What is the question is, note on the question, important question. What is the maximum page size in bytes? What is the maximum page size in bytes? See that we don't know what is the maximum page size. We have to find out page size. Page size we need to find out. It's not given. Page size is not given. We need to find. Page size has to be found in bytes. So that page table for a segment requires at most 1 page to store it. Question is, what is the maximum page size in bytes, so that the page table for a segment, a page table, this is a page table for a segment, requires at most 1 page to store. This page table has to be 1 page, should be like 1 page store, 1 page. We don't know page size. This page size and page table should be less than or equal. That is the question, right? Let us solve this problem. Coming to the solution part. Virtual address is given 2 power 16 byte, physical address is 2 power 15 bytes. Now, process is divided into 8 equal size segments. Now, page table entry size is 2 bytes. Page table entry size is equals to 2 bytes. This part is given by difference. We need to find what is the page size, what is the logical address. It means what is the segment, how many segments, page number, offset. We are going to calculate these 3 from this problem. Okay. Solution is, let the page size is, let the page size, we don't know what is the page size. Let it be, let the page size is n bytes. Assumption, page size is n bytes. Now, page table has to be stored into a single page. So, we must have size of the page table, size of the page table less than or equal to page size. We don't know what is the page size, but page table size should be less than or equal to page size. These are the question. We need to find page size. We don't know, that is n bytes. Size of the page table we need to find out, and that size of the page table should be less than or equal to page size. Okay. Now my dear friend, size of each segment. Size of each segment. How many segments? 8 segments. This is 8 segments. Virtual address space is 2 power 16. 2 power 16 bytes by how many segments? 8 segments. Then we'll get what is the size of the each segment. Now 2 power 16 bytes by 8 is equals to 2 power 16 by 2 power 3 is equals to 2 power 13 bytes. Okay, my dear friends, this is 2 power 16 bytes of space is divided with into 2 power 13 bytes. This is like one segment size. This is total size. This is one segment. How we got one segment? 2 power 16 by 8 segments is equals to 2 power 16 by 2 power 3 is equals to 2 power 13 bytes is equals to 8 KB. So one segment, each segment size is equals to 8 KB. Okay, each segment size is equals to 8 KB. Now we found that each segment is 8 KB. Each segment is 8 KB. Number of pages of each segment. Now, number of pages. 8 size, segment size 8 KB. Okay, we found recently. Now number of pages of each segment, number of pages of each segment is equals to number of segment size is 8 KB, but page size we don't know. If we divide with n, page size we assume, our assumption is n bytes. N bytes. This is number of pages of a segment is 8 KB by n. Bytes is number of pages of each segment. Means page table. In page table, how many entries? 8 KB by n entries are there in page table. This page table for one segment is 8 KB. For 8 KB segment, for this 8 KB segment, we created a page table. We divided with the page size. We don't know that our assumption is n bytes. Then we got page table. This many entries. Each entry how many bytes in the question? It's given 2 bytes. So what is the size of this page table? Now we will calculate, my dear friends, size of the each page table. Size of the page table. Size of the page table, how can we calculate? Number of entries into each entry 2 bytes. That is size of each page table is equals to number of entries. Just now we are seeing 8K by n into 2 bytes. By 2 bytes, each entry 2 bytes in the question it is given. This is 16K by n bytes. This is the page table size. What is the PT size? PT size of a particular segment. Each segment has Each segment has its own page table. Okay, a particular segment, that corresponding page table size is, this is the size is 6K, 16K by n bytes. Okay, my dear friends. Now, the question is, this page size should be less than or equal to, page size should be less than or equal to, page table size should be less than or equal to page size. Now, page table 16K by n, we got less than or equal to n bytes. This is given in the question. What is the question? This is page table size. Page table size should be equal to page size. Okay, that is given question, we are substituting. Now we found 16K by n is page table size. This is the page size. From this we will calculate n. This is nothing but n square greater than or equal to 16K. Mathematical, simply. If you bring this n square is always greater than 16K. Now, n square is equals to 2 power 14, where n greater than or equal to 2 power 7. Now we got 2 power 7. 2 power 7 means 120 bytes. So from this, the page size is, we calculated page size. Yes, we calculated page size. Page size is, now, page size is 2 power 7 is equals to 128 bytes. Now we got page size. Understood? Now using page size, now we can calculate 16 page table. Since we don't know n, we found 16K by n. Using this page table size also, we can easily calculate. Now let us see the address part. Number of bits required. The first part we got. First question, page size means 128 bytes we got. First the question, we got the answer. Next, number of bits required for segment number. Address, logical address we are finding. Now logical address. Number of bits required for segment. CPU generated segment number, page number, offset, right? Now we are going to calculate this logical address. How many bits for segment, how many bits for page number, how many offset. Now we are going to calculate in this problem. Now number of bits required for segment number. Segment number, how many bits, how many total segments? 8. So 2 power 8, 2 power 3 is equals to 8 segments. So how many bits we need here? 3 bits we need for segment number. Okay. Next, number of bits required for page number. Page number. Number of bits required. For page number. This is, my dear friends, this can be calculated. What is the segment size by? Segment size is 8 KB and page size is 128 bytes. If we divide this segment by, segment is divided into number of pages. If we divide this, my dear friends, 2 power 3 into 2 power 10 by 2 power 7. And this you will get here, my dear friends, 2 power 6 pages. This will be 2 power 6 pages. 2 power 6 pages. So how many bits you need? 6 bits we need, my dear friends. Number of bits for page offset. Page offset means page offset. Page offset, what is the D? D is equals to page size is equals to frame size. What is the page size? 128 bytes is equals to 2%. So 7. The CPU generated, my dear friends, 3, 6, 3, 7. Understood? This is 3 for what? 8 segments. This 6 in a particular segment, how many pages? 2 power 6 pages. Okay. The page size is 128 bytes. We need 7 bits as an offset. Okay, my dear friends. This is segmented paging. The given program is divided into segment. The segment size always varies, not a fixed. And each and every segment is divided into number of pages. And we need to maintain a page table. Same how a segment is divided into number of pages. The page table again gives direction to the frame number. Which page of the particular segment stored in which frame in the main memory. So this is the sophisticated thing to implement paging, segmented paging, my dear friends. It is very complicated. Only in Pentium systems right now they are using segmented paging. Thank you so much for listening to the class. Next class we will discuss about demand paging. Thank you.